So essentially, you can compensate. Now, all of these, you can, for example, you can think of airbags, bending knees, water buckets, and padded barriers. As all of these things rely on increasing time to decrease force. So remember that impulse again is J, and J is equal to the integral of F dt, and this means what force does over time. And change in momentum is simply going to be delta P, and delta P is going to be equal to m delta V, and this is going to be the object's response. Now, here is the relationship between the two. It's just going to be J is equal to delta P, and then this is force time. It creates delta V. Now let's continue with this. On the graph, remember the height is going to equal to the magnitude of the force. Remember, the width is going to equal to the delta t duration. Remember that negative area is negative impulse. Momentum decreases that direction. Okay, now you could also rewrite, when you use each impulse formula, this is going to be when only velocities given. This is when you need average force. This is when you have, where is, yeah, that is constant force. Let's see, impulse sign direction. Okay, now let's talk about the signage. What does it mean when it's different signs? So let's say you have a negative P. This means that it's reverse direction. And that means that impulse opposes the motion. Okay. Positive P means speed up impulse in direction of motion. Okay. And then let's say you have, but also remember that negative P again can also mean that that the object is also slowing down. And then this would mean that the impulse again is in the opposite direction. let's move this up here. Let's see. If object reverses its direction, delta P will become large because both sign and magnitude will change. Now, if the object is thrown up or down, sign tracking determines the impulse direction. Now let's say that you're reading it from on the graph. Like again, graphically. Graphically, we know that, again, the rectangle is F times T. That's constant force. What is the triangle? Is 1/2 force times time, and that's linearly increasing, decreasing force. Now, a trapezoid. This is going to be 1/2 F1 plus F2 times time. And this is going to be a piecewise force change. Now let's say that we have irregular. This means you just count grids. Just count the grids. Okay, average force. Let's go back to talking about the average force. So for average force, longer impact means smaller average force. And shorter collision means larger average force. And this is why crumple zones decrease injury. So think of like a car inflatable thing. Airbags actually extend collision time. And also this is why with soft hands, on your hands. Now let's see, let's talk about rebounding objects. So for rebounding objects, if an object strikes if an object strikes a wall and reverses direction, that means that that means that P initial is equal to positive MV initial. Let's just use I for initial. And that means PF is equal to negative MVF. From delta P is equal to M negative VF minus MVI. This will become a large negative number. That will become a large impulse magnitude. So you need to be able to compare, for example, bounce versus no bounce. Also, you need to be able to compare elastic versus inelastic collision with the wall. Also, which one has the larger impulse? Bounce will have the larger impulse. Now, let's always remember, for when you're assigning J, always assign direction first. Okay? And remember that it's delta for here. Remember delta. Remember also that you need to that in general the definition of impulse is the effect of the force. So that's the cause. Now let's see. That is basically everything. All right.